This is one of my solar heaters, and it is made up of these sheets of mirror steel that focus solar radiation into this spot, which should be on the surface of similar receiver. It is desirable that the receiver be covered with a similar transparent sheet or film, and now I am showing the pipes which form that receiver, and these metal surfaces were heated by that spot of solar radiation. I have tested this system many times in different situations. You may notice its similarities with this old method of generating electricity, and more than 100 of these solar power plants have already been built, and for example, this power plant cost about $2 billion. Their mirrors focus solar radiation into this receiver, where the radiation heats thermal oil to almost 400 degrees Celsius, which produces steam to generate electricity. This old method is better than solar panels due to the fact that solar electricity is generated both day and night, because the hot thermal oil heats up these thousands of tons of substance during the day with the goal that this thermal energy will produce steam for the same turbine at night. Several sheets of mirror stainless steel were used in my solar station, and you can see them here. My solar heaters are almost 20 times cheaper than these mirror systems, but unfortunately they are not capable of producing high temperatures for the turbines, and therefore we must change them as follows. This sheet of stainless steel must be turned into a concave dish, and my previous videos often showed how a row of motionless mirror dishes focus solar radiation into these receivers, which must move according to the movement of the sun across the sky. We must distinguish our method from this well-known method when a mirror dish moves together with this receiver, and from this Indian method when a dish moves to constantly focus solar radiation into this motionless receiver. I repeat that our receivers move, but our mirrors are stationary, and my previous videos often showed the behavior of this solar radiation spot on the surface of our receiver from morning to evening. I am currently publishing videos which methodically describe 10 types of cheap mirrors, and stainless steel mirrors are one of those 10 types. The mirrors of my experiments were steel of this grade with a thickness of 400 microns, and it is the cheapest mirror stainless steel with a wholesale price of less than $80 per square meter. Now I will show one of my stainless steel mirrors after 8 years of its operation outdoors, and we understand that the lifespan of these mirrors is several decades. It is interesting to look at this situation a week after hail with a diameter of up to 15 mm, which made a lot of these dents on the surface of the aluminum sheet, but this stainless sheet withstood the hail without any dents. Other features of stainless steel mirrors were described in these two of my old videos. I am trying to get my solar heaters to meet this formula, which leads us to this cost of our solar heat, half a cent per kilowatt hour. It is 10 times cheaper than the cost of heat from natural gas, and therefore leads us to the production of electricity, which is cheaper than electricity from thermal and nuclear power plants. It is obvious that our solar power plant must consist of millions of mirror dishes that will provide a temperature of up to 300 degrees Celsius for the thermal oil, which circulates between these pipes and the center of the power plant. The hot thermal oil produces steam for turbines and heats up huge masses of concrete, sand, or other cheap materials inside heat storages, various designs of which were described in this my old video. Those hot masses will produce steam for the same turbines at night and on cloudy days. Of course, the technology of making metal dishes is well known because humanity produces hundreds of millions of satellite dishes per year, but I also experimented with simpler ways of making them. For example, here we see how one of my mirror dishes focuses solar radiation, and it consists of these 7 curved reflective sheets. This is my other option, and its focusing of solar radiation is here.